students. Today we are going to see some compounds of transition elements in chemistry. Compounds of transition elements. That is, first we are going to study the KMnO4, potassium permanganate. It is a compound of manganese, and KMnO4 called as potassium permanganate. First, I want to tell you what is permanganate and what is manganate. KMnO4 dissociates as K plus and MnO4 minus, one positive charge on K plus, one negative charge on MnO4 minus, which is called as potassium permanganate. We used in the laboratory. But if there is a K2MnO4, that means there have been two K plus ions and MnO4 on MnO4. As there are two positive charges on MnO4, there must be two negative charges. Means this is the MnO4 minus or 2 minus. Here MnO4 minus called as permanganate. Remember that we regularly use this permanganate in laboratory. K2MnO4, if there are the 2 minus charge, then it is called as only manganate. MnO4 minus manganate. MnO4 minus, that is in KMnO4, potassium permanganate. K2MnO4, potassium manganate. The color of the potassium permanganate, color is necessary to know in the multiple type questions. The color of the potassium permanganate is dark purple. You know, we used it in the laboratory for the volumetric analysis or the titration. If it is in solid form, then it looks like a dark purple, that is near about the black or black purple color. And in potassium manganate, color of the potassium manganate is green. Means if there is a green compound, it is of the potassium manganate. If purple, then it is of potassium permanganate. Remember the color as well as the charges of the permanganate and the manganate ions. And now we are going to see the preparation methods of potassium permanganate. Preparation methods. First preparation methods is chemical oxidation. Means oxidation using the chemical substances. Chemical oxidation. Here the black powder which we use in the laboratory, that is the MnO2, manganese dioxide, and treated with diffused mass of caustic potash, that is potassium hydroxide, heated with the potassium hydroxide in presence of oxidizing agent potassium chlorate. This manganese dioxide heated with the fused mass of potassium hydroxide or caustic potash, and this potassium chlorate is act as an oxidizing agent. And in this step there is the formation of the thrice K2MnO4 plus KCl plus thrice H2O. Here oxidation state of manganese. Oxidation state of oxygen is -2. Total oxidation state of O2 is -4. of manganese is +4. In case of K2MnO4, oxidation state of oxygen -2. Total -2 into -4 -8. Oxidation state of K +1. Where K2. Therefore total is K2. -8 + 2 is equal to -6. Total charge is 0. Therefore oxidation state of manganese is +6. See again. O4 that is -8, K2 +2, -8 +2 that is -6. -6 plus is equal to 0. This oxidation state of manganese changes from +4 to +6. As oxidation number increases, it gets oxidized. And as KClO3 is oxidizing agent, it oxidizes MnO2 to K2MnO4. K2MnO4 is the potassium manganate and not the potassium permanganate. And in next step, this in either in acidic medium or in neutral medium, this potassium manganate get converted into potassium permanganate. When in neutral medium, this potassium manganate is treated with CO2, or if CO2 is passed through this potassium manganate in aqueous solution, that is 8K2MnO4 plus 4CO2 plus twice H2O, means aqueous solution of potassium manganate. If we pass CO2, then there is formation of the twice KMnO4 plus MnO2 plus 4KHCO3, potassium hydrogen carbonate or potassium bicarbonate. Means here K2MnO4, potassium manganate get converted into potassium permanganate by passing the carbon dioxide through the aqueous solution. That is, this is formation of potassium permanganate in acidic medium. If potassium permanganate is formed, that is in neutral medium. Now we are going to see formation of potassium permanganate in acidic medium, where only ions are taken, that is trans MnO4 2 minus. 2 minus means these are the ions of the manganate. In acidic medium, therefore there are 4H plus. There is formation of the twice of MnO4 minus, single minus, means this is the potassium permanganate plus MnO2, manganese dioxide, and twice H2. This is the formation of MnO4 minus, that is the permanganate from the manganate ions in presence of acidic medium. If preparation method is asked in the exam, then reaction should be balanced. You have to practice of this reaction. And this solution of potassium permanganate prepared in this next step. That solution is filtered through the glass wool, evaporated, and there is a formation of the dark purple black colored crystals of the potassium permanganate. This is the first method, that is the chemical oxidation. And the next method of preparation of potassium permanganate is the electrolytic oxidation. Electrolytic oxidation of course, potassium manganate. As this is an electrolytic oxidation, there should be electrolysis, that is the solution of potassium manganate, KMnO4. This solution is oxidized in between the iron electrode, and as it is solution is electrolyzed in between the iron electrodes, and oxygen which is evolved at the anode oxidizes this K2MnO4, that is potassium manganate, into the potassium permanganate. The reaction of this electrolytic oxidation, again I will repeat, the K2MnO4, that is the potassium manganate, is electrolyzed in between the iron electrodes, and oxygen which is evolved at the anode oxidizes the potassium manganate to the potassium permanganate, and the reaction is twice of K2MnO4 plus H2O plus oxygen which is evolved at the anode in the electrolysis process. Then there is formation of twice of KMnO4, that is potassium permanganate, plus twice of KOH. As the formation of the solution of potassium permanganate, that solution is filtered and evaporated. Then there is formation of the crystals of potassium permanganate, which have the dark purple color, which is our purple black color formation. This is the preparation methods of the potassium permanganate. Then the chemical properties of potassium permanganate. Potassium permanganate, this potassium permanganate is act as a oxidizing agent. We are going to see the reactions of the potassium permanganate in acidic medium and in basic medium. For acidic medium, remember the oxidation state of iodine changes from I- to 0, increases from I- to 0 in acidic medium. In basic medium, it is from I- to, we will see later, I- to I+5 in basic medium. But in acidic medium, from -1 to 0, and oxidation state of manganese changes from +7 to +2 in acidic medium. This is for the, remember, that is in acidic medium I- to I0 and Mn+7 to Mn+2 means iodine get oxidized manganese, and oxidation number reduces, manganese get reduced. So here Mn. Then means acidic potassium permanganate or alkaline act as a oxidizing agent in acidic medium. First reaction is oxidation of iodide to iodine. Oxidation of iodide, that is I- to iodine. Reaction for that is twice MnO4 minus. A single minus charge means now we are going to see the reactions of the potassium permanganate and not the manganate. Therefore, these are ions from the potassium permanganate. Consider it as a potassium permanganate. That is the twice of MnO4 minus plus 10 I- iodide ions. As medium is acidic, there must be H plus ions plus 16 H plus, formation of the 2Mn 2 plus 8 H2O plus 5 I2. Here consider the oxidation state of manganese. And in oxidation state of oxygen is -2, therefore total of O4 is KMnO4 is -1. Therefore, -8 plus 7 equal to -1. Therefore, oxidation state of manganese is +7. As already I told you, oxidation state of manganese in acidic medium changes from +7 to +2. Here oxidation state of I is -1. Here 5I2. In elementary state, oxidation state of iodine is 0, means it increases from -1 to 0. Oxidation of iodide ion and reduction of permanganate ions means permanganate ion itself get reduced and oxidizes the I- ions or iodide ions to the I2, and thus the potassium permanganate or permanganate act as a oxidizing agent. If you use the first edition of the textbook, then correct here in your textbook there is a 5I2 and not only I2. This is the correction in the first edition textbook. This is the conversion of I-4, then oxidation of Fe+2 to Fe+3. Fe+2 to Fe+3. That is Fe+ get oxidized to Fe+3 by using the potassium permanganate. As atomic number increases, which indicates the oxidation reaction for this MnO4 minus, that is permanganate ions, plus 5 Fe2 plus 8H plus, as this is the in acidic medium. These 2 plus are oxidized to 3 plus 3 plus and oxidation of Fe2 plus. As it get oxidized, it should get reduced. In acidic medium, Mn+7 to Mn+2. Hence, there is a formation of the Mn2 plus ions plus 4 H2O. Reaction should be balanced. When potassium permanganate or permanganate ion treated with the Fe+2 in acidic medium, Fe+2 get oxidized to Fe+3, and this manganese at oxidation state +7 is reduced to +2. And there is formation of the water molecules also. This is the oxidation of the iron Fe+2 to Fe+3, then oxidation of H2S. Here in H2S in acidic medium, oxidation state changes from S-2 to S0. Oxidation increases from -2 to 0. S get oxidized and manganese get reduced, as permanganate ion oxidizes S-2 to S0, and hence here also KMnO4 or potassium permanganate or permanganate ions act as an oxidizing agent. Reaction is H2S dissociates as twice H plus and S minus ions. Means in H2S there are the 2 negative charges on the S plus ions, and the ionic reaction is 5 S minus plus 2 MnO4 minus, that is manganate ions in acidic medium, therefore 16 H plus ions produce 2 Mn2 plus, that is at +7 to reduces to +2. 5S plus here 8 H2O. Here oxidation of the H2S, that is S-2 to S0. Here S minus, as there is a formation of the neutral sulfur, this oxidation state is 0. In MnO4 minus, oxidation state of Mn is +7, and here oxidation state is +2. That means the oxidation state of Mn reduced oxidation state of S minus is increased. Hence oxidation of the S minus and reduction of the permanganate ions. This is the oxidation of the sulfide ions, and next is the oxidation of oxalic acid in acidic medium. What is formula of oxalic acid? H2C2O4. What is the oxidation state of oxalic acid in oxidation state of carbon in oxalic acid? Oxidation state of oxygen is -2. Oxidation state of O4 -8. Oxidation state of hydrogen is +1. 2 hydrogens +2 -8 +2, that is the -6. Hence oxidation state of 2 carbons is the +6. Hence oxidation state of only single carbon is +3 in oxalic acid. Then reaction price of KMnO4 minus, that is permanganate ions, plus 5H2C2O4. As in acidic medium there are 6 H plus ion. In H2C2O4 oxidation state is +3. In MnO4 minus oxidation state of Mn is +7. Then there is formation of the twice Mn +2 ions plus 10 CO2 plus 8 H2O. First we are going to see only the reaction. Permanganate ions treated with the oxalic acid in presence of the acid. While in acidic medium there is a formation of the Mn +2 ions, 10 CO2 and H2O. Here if we see the oxidation state of Mn +7, it is reduced to +2. Itself gets reduced, but it oxidizes the oxalic acid and hence it acts as a oxidizing agent. The oxidation state of oxalic carbon in oxalic acid is +3, and in case of CO2, O2 total -4. Therefore in CO2 oxidation state of carbon is +4. Oxidation state of carbon increases from +3 to +4. Hence it gets oxidized, it gets reduced, and KMnO4 or MnO4 permanganate ions act as an oxidizing agent. These are the reactions in acidic medium. Then reactions in neutral or weakly alkaline medium. Reactions in neutral or weakly alkaline medium. Reactions of here again potassium permanganate, but medium is changed, that is the alkaline or the neutral medium. First also the oxidation of iodide to iodate. IO3 minus is called as iodate. In acidic medium there is formation of the I minus to I2. In basic medium or weakly alkaline, I minus to IO3 minus, that is the I minus to I plus 5. Reaction twice MnO4 minus plus H2O plus I minus, formation of 2MnO2 plus 2OH minus plus IO3 minus. Here potassium permanganate or permanganate ions are when treated with the iodide ions, there is formation of the MnO2, OH minus and iodide ion, that is the IO3 minus. Here this is a neutral or weakly alkaline medium. In IO3 minus, oxidation state of iodine is IO3 minus. Oxidation state of oxygen -2, total -6 O3G. Total sum is the -1, their oxidation state of iodine is +5. Means in IO3 minus, oxidation state of iodine is +5. Means it changes from -1 to +5. As it changes from -1 to +5, there is increase in oxidation state, and means it gets oxidized. In case of MnO4 minus, oxidation state of manganese is +7, and in MnO2, oxidation state of O2 is -4. Therefore, oxidation state of Mn is the +4. Means from +7 to +4, that is, it gets reduced and it oxidizes the iodide to iodate ion. Then here also this MnO4 is act as a oxidizing agent. This is the oxidation of I minus, then oxidation of thiosulfate. Thiosulfate, that is S2O3 2 minus. Oxidation of these thiosulfate ions by using permanganate ions. Reaction is 8MnO4 minus plus thrice H2O3 2 minus, that is thiosulfate ions, plus H2O neutral medium 8MnO2 plus 6SO4 2 minus plus 2OH minus. Means in this permanganate ions treated with the thiosulfate ions in neutral medium, there is a formation of the MnO2 and these sulfate ions. In S2O3, what is the oxidation number of S? O3, that is total -6, total charge is 2 minus, means it has the +4. -6 plus 4 minus 2 means here sulfur has oxidation state +4. In case of SO4 minus, oxidation state of total O -8, total charge -6, means -8, total charge is -2, means its oxidation state is +6. That is increased from +4 to +6. As increase in oxidation number, it gets oxidized, and permanganate ion oxidizes the sulfur from +4 to +6, and that get permanganate ion act as an oxidizing agent. Here charge oxidation state in MnO4 minus is +7, and in MnO2 that is +4, means it get reduced but oxidizes the sulfate ions. This is the oxidation of the thiosulfate ions by using the permanganate ion. And the last one is the oxidation of manganese salt in MnO2. Manganese salt to MnO2. Twice of MnO4 minus permanganate ion plus 3Mn2 plus is Mn2 plus from the manganese salt. Therefore, only Mn2 plus 2H2O 5MnO2 plus 4H plus. Here oxidation state of Mn is +2. Here oxidation state of Mn is +7. Here oxidation state of Mn in MnO2 O2 -4, total -4. Therefore, Mn oxidation state +4. Means this Mn+2 ions from manganese salt get oxidized. Mn2 plus to 4 plus. but this Mn plus 7 to plus 4. Here also Mn, here also Mn. It get reduced. This Mn4 ions, KMnO4 minus ions get reduced, but Mn2 plus ions get oxidized. Hence, these permanganate ions act as an oxidizing agent, and it oxidizes Mn plus 2 from manganese salt to the MnO2 manganese dioxides. Then the uses of the KMnO4 potassium permanganate. It is act as an antiseptic. तुम्हाला कधीतरी आठवत असेल डॉक्टरांनी पोटॅशियम परमॅंगनेटचा पर्पल कलर दिलेला असतो, त्याचा चुळा मारायला सांगितलेले असतात, म्हणजे ते अँटीसेप्टिक म्हणून ऍक्ट होतं. पोटॅशियम परमॅंगनेट इज ऍक्ट ॲज अ अँटीसेप्टिक. इन दिस रिएक्शन्स वी सी दी potassium permanganate act as an oxidizing agent. Then potassium permanganate is used in volumetric analysis of the reducing agents also. We are using this potassium permanganate purple colored solution in laboratory. That is, we are using this in the volumetric analysis of the reducing agent like FAS, oxalic acid, etc. Also, this is used for detecting the halides in qualitative analysis. These are the uses of the potassium permanganate. Thank you. In next lecture we are going to see the potassium dichromate.